Okay, here we go. First of all, I want to draw attention to the fact that this is not an equation. There's no equal sign. It's an algebraic expression. But if I want to find the partial decomposition of this function, there's a theorem that says that it's going to look something like this. A over x plus b over x squared plus c over x plus 1, d over x plus 1 squared, e over x plus 1 cubed. And so what we're going to want to do is take this equation and multiply every term by the LCD, which happens to be this. So we'll get the numerator equals, and as we multiply the LCD times each term, these denominators cancel out. So you can kind of look at the LCD and see what factors remain. And this does continue down here, plus dx squared times x plus 1 plus ex squared. Okay, now here's a little trick you can do to simplify the system of equations you're going to end up with if you equate coefficients. If we let x equal 0, this left side becomes just a 4. And if we put 0 in for x on the right side, all these terms become 0. And we're left with 0 plus 1 cubed times b, or just b. So b is 4. We've got one of the variables already. And if we let x equal -1, you have to picture substituting -1 in for x on the left side. I'll leave the simplification to you. That's -5. And on the right, all the terms containing x plus 1 disappear, and we're left with just ex squared. -1 squared is 1. So -5 equals e. So just like that, we've got two of the variables. And if we go to board 2, we can see maybe how you can organize your work. Here's b, here's e. So ax times x plus 1, the quantity cubed. Now we want to equate coefficients. So we're going to have to expand this. X plus 1, the quantity cubed, is x cubed plus 3x squared plus 3x plus 1. I'll leave that to you. Distribute the ax, and this is what you end up with. Similarly, distribute the 4. I put this 0x to the 4th in here as a placeholder for equating coefficients. Cx squared looks like this. Cx squared times x plus 1, the quantity squared, looks like this, and so on. And here's that e. Now it's time to equate coefficients. So I'll go to red. Here are the coefficients of x to the 4th right here. And the sum of those coefficients has to equal -2. So a plus c has to equal -2. For x cubed, the sum of the coefficients has to equal this 2. There we go. And similarly, for the x squared coefficients, have to add up to 6. The coefficients of x have to add up to 11. And of course, this 4 is equal to this 4. Well, look what happens. Right here, a plus 12 equals 11. A equals -1. And as soon as a equals -1, c equals -1. So we've got 2 more of the coefficients. All we have to find is d. We know a, b, c, and e. So if we look at this equation right here, plug in -1 for a, -1 for c, we can solve for d. We get d equals 3. If you wanted to put the same numbers in here to confirm, you'll see that that one's true also. So sometimes it doesn't work out this convenient. You have to set up a system of equations in 2, 3, 4 unknowns and solve the system. But this one went pretty well. And here's how you confirm your work on Desmos. If I write f of x equals the initial function, and then here's g of x broken apart with its partial fraction decomposition. This was a, b, c was -1, d was 3, e was -5. And you can compare on Desmos that these two functions have the exact same graphs. If you want to convince yourself even further, you can create a table and show that any value you plug in for x of 1 gives you the same value for both functions. So there you go. That gives you some idea how to organize your work when you're doing these problems. It can get pretty complicated, and so you have to organize your work. There you go. Hope that helped. If you have any questions, post a comment.